Okay, in this video, we're going to look at the process of sloping a roof structure. So now let's just say we have a building like this, and usually the intent or the design approach to sloping roofs for larger commercial buildings is not to slope to the outsides. Okay, that's not usually the approach like you'd see in residential. The approach is to slope inwards from the parapets, okay, to various roof drains on the building. So how we can slope there, there's a couple of ways we can do this. We can slope the insulation, or we could slope the structure. So let's just talk about that a little bit. So if we were to slope the insulation, let's just zoom in on this a little bit. You might have a flat roof structure here. Okay, so that's going to be the roof structure, and let's just say that it's flat. So you're going to have a requirement for a base amount of insulation on that building. So let's just say that's that base amount. And we're going to drain this thing to the middle. So let's just put a big red line here, and that's going to be the drain point in the middle right there. We'll get to how we're going to do that later. But if we were going to not slope the structure and just slope the insulation, we would still have a requirement, a minimum requirement kind of at the low point of that insulation. A minimum energy code requirement for a certain amount of insulation there. I mean, you can factor it in as the whole roof. I guess the effective R value could be across the whole roof. But you don't want to obviously have only maybe 1 inch or 25 mil of insulation at the lower points. Basically, you still want to have a decent amount of insulation there. So what ends up happening is if you were to slope the insulation, you would put some tapered insulation boards on top of there, like so. Okay, so that is certainly an option to taper the insulation. It's got to be fabricated that way, and it obviously installed kind of like a puzzle, I guess, based on the fabrication. There'd be shop drawings that do that, but a lot of cost basically to do this. So you've added more insulation than you maybe want. I mean, that's a good thing from an environmental standpoint, I suppose, but you've added more insulation than maybe you want, and you want to pay for. Basically, let's put it that way. So sloping the insulation will probably give you more insulation than you want to pay for. And secondly, the other thing you got to pay attention to is your parapet height. So obviously, the farther this distance is from here to here, you're going to want to achieve the ideal is about a 2% slope. That would be the ideal situation. So if you went 2% over, say, a 9-meter distance, that would be an extra 180 millimeters of insulation right there. Okay, so that's just one example of how much extra insulation would be there. So you also have to pay attention to, well, what is that parapet height, right? So now all of a sudden you could have an impact on your parapet height, right? Because you're going to want to make sure that your parapet's higher than the top of the insulation, obviously. And the other thing that you want to consider as well is that the roofing manufacturers, a lot of the membranes that you use, like to see a 200 upturn for that roof membrane to come along the roof and go up and over the parapet like so. So sloping the insulation is certainly an option, but there's a lot of cost there. The cost of the insulation itself, the labor to do it, and then you may have impacts to the building facade, adding higher parapets, which means more cladding and all this kind of stuff. So that's just something to be aware of when you slope insulation. Now, what's interesting about the second approach here of sloping the structure is that whatever your structure is in here, okay, so let's do it in something we can see here. Let's do green. So we got a beam maybe here. I guess I should draw it lower because I'm going to slope my structure. There's a beam there, and we have steel joists or whatever, okay, and they're going to slope down to that beam. The interesting thing is that we can just drop this beam in the middle so that these joists are sloped down like so. And there's really no extra cost to that. Like you got to put that, regardless, even if you did a flat roof, you still need that beam, right? So if we just go back to our sloped insulation situation and draw in this structure, you'd have a beam in the middle. I guess I should put my joist seat in there, but whatever, you get the point. You have the beam in the middle, and you have your joists. Okay, So you've paid for that anyways. You paid for that joist, you paid for that joist, you paid for that beam. Why not just slope it? Okay, because by sloping that stuff, and I'll just draw it drastically here. So it's easy to see. There's the beam, and here's now that joist. By taking that approach, there's no cost really. Maybe there's even a savings because you've just used less steel. The column, that would be that the beam would attach to is not as tall anymore. So, and steel is often paid for by weight. So I don't think it would amount to much, but obviously there could be a savings in there. So, I think the big takeaway is um, that you got to build that structure on the roof anyways. So if you can slope the structure, why wouldn't you? A person could also consider, I suppose, over the lifespan of the building, I guess having a sloped structure is kind of dummy proof as well. So you are going to replace your roof over time. Um, would the people that are replacing the roof know if you had a flat structure system, would they know to do the tapered insulation or whatever? Probably, but I suppose it is dummy proof to slope the structure because they could just go in there and do their basic roof with one thickness of insulation, and it wouldn't be a problem. You would still have the slopes. So anyways, those are some considerations to the two approaches that are generally used for getting a slope on the building. Okay, so now the discussion gets to, okay, how do we do this? Okay, so this basically works with your grid system. So what I've drawn here is some grid lines in a building. So in this case, the building outline would be along the exterior grids right there. And again, we want to slope in from the outside. And so generally how I approach this is a high point, low point sequence, basically. So we know if we want to slope the water inwards to some drains, that we want the perimeter of the building to be the high point. And so really all I do is I say, okay, this is a high point, this is a low point. This can be a high point, this can be a low point, this can be a high point. That works out perfect. On the other side, high point on the perimeter, low point, high point. And so what I've done here is if I just draw lines on the high points, I've created that situation. Okay, now remember our beams run one direction. So let's just assume the beams are going this way in this building. Okay, so here's on the interior, they run one direction. So there's beams here, beams here, beams here, here, and here. And the joists are going the other direction. So what that means is these two beams here are going to be flat. Okay, they're going to be at a certain height, and it should be the same height as the one on this end and the one on this end. Now the ones on these two ends, because the joists are running this way, these two beams are actually down a little bit because there's no joist seat, or sorry, raised a little bit because there's no joist seat, but that's besides the point. The point is all the green areas, the beams are flat. But what we can do with these other beams here is slope them, right? So the magic number seems to be, let me just find a good color here, we'll do it in red. The magic number seems to be minus 150, minus 150. And so what that means is that, there's going to be a column here, and your beam's going to come across and attach to that column, your beam's going to come across to touch. So what that means is this is going to be a zero height at this end, so the beam's going to attach at a high point on these two ends, and then we're just going to lower it down 150 millimeters where it attaches to the column. Okay, and by doing that, and the joists can just span across, there's nothing special with the joists, they just make up for that span, and then what we've ended up doing is creating a slope that kind of looks like that. Okay, so that way, that way, that way, and that way. And then of course, you would just put your roof drain in that general area of the low point. Okay, and so if we look at this whole building, again, if we did the same thing, you would end up with a slope that looks kind of like that. And essentially, there's my roof drain. And essentially, you've got no cost to doing that. That's a very straightforward roof plan right there. So obviously rectangles and squares work out pretty well. That's not always the way our buildings are, but that's the approach of how to see if it's possible to slope your roof structure. A couple other things I'll just say with this is that, you certainly don't want to just have one roof drain on a building. So let's just say it was, if your building was this right here by itself, you always want to have secondary drainage points. So usually the cheap option is, if you look up at the parapets of buildings, there will be a hole in the parapet. Let me find a nice bright color here. There will be a hole in the parapet, maybe there, 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 and there. It's usually just a little rectangle, like maybe 200 millimeters wide by 450 long or something like that. And really what that is if this roof drain right here got plugged up and water started to pool on the roof, it's only going to pool so much, and the engineer can design to that. And then at some point, as the pooling happens, it's going to go through those emergency overflow scuppers, they're called. So that's one option. That's the most common option because it's quite cheap to do. Again, not always possible to do the scuppers, the overflow scuppers. So there is other options where you can do a secondary roof drain system. So there's one roof drain. You could have another roof drain right near it, but that roof drain has a wall around it. Okay, that is maybe, so it's not used all the time because there's a barrier around the roof drain of a certain height. So that height would be 150 millimeters probably. So it would allow allow the water to pool to a certain point, and at a certain depth, it'll start going into that secondary drain. And then, mechanical takes it over from there. But there is the option to do a secondary drain system as opposed to the emergency overflow scupper. But yeah, you'll very often see, if you start paying attention to buildings, look up at the parapet and you'll often see the holes in the parapet, and that's just for drainage in an emergency situation. They shouldn't be used. You shouldn't see water dumping out of them, but they're there for that emergency purpose. And so I always get asked, where does a 150 come from? I'm not 100% sure. Like, I know at one point when I was working on buildings, we used to do more. Like, we always want to try to achieve that 2% slope. So obviously, depending on your grid bay dimension, you might not get that 2% slope. So sometimes we would say, well, instead of 150, let's take it down to minus 200 to get that 2% slope. And I don't know where it came from. It might have been the plumbing code or something, but it was from the mechanical engineer, I'm sure, where at some point there was a requirement that you couldn't have that overflow, that emergency overflow, more than 150 millimeters high. So what that ended up doing is just basically making some of the, if you have a larger grid bay, like 9 meters plus and stuff like that, then you might not quite reach that 2%, but it's okay. I mean, the roofing manufacturers will want, they ask for 2% is the ideal, but if it's 1.25 or 1.5, like whatever, it's fine. Just be clear about it on your drawings as to what it is, so that when the roofing manufacturers are bidding on the project, they know what it is and they don't try and weasel out of the warranty because of a lower slope. Okay, so that last roof worked out pretty good. What I've done here now is drawn one more grid line, so that's not going to work out so good. It's still a pretty basic situation here, but this is the foundation of how you approach this. Okay, so now we've got one more grid bay in here. So if we do our high points, so there's going to be a high point on the exterior again, low point, high point, low point, high point, low point. It's like, ooh, I don't want that. I want a high point on the exterior, so that's no good. So what I can do at that point is just say, okay, well, I know this is a high point, so I'm going to make that a low point as well. Okay, so on this side, I haven't changed anything, so high point, low point, high point. And so now if we draw our colored lines on our high points here, we have high points around the perimeter again. Okay, and we've got a high point right there. So what we've done here is created a, and we would put this at minus 150. And now we're going to put that at minus 150 and that at minus 150. And what we've created here is this situation right here. So our roof slopes like this, okay, on that side. And now on this side, the problem we have is we're going to get this happening, right? So these two, that beam there is sloped from a high point to a low point. This beam here is sloped from a high point to a low point. This one here is sloped from a high point to a low point. And this one here is sloped from a high point to a low point. And so what that's done now is there's a low point here and a low point here. So there's a flat spot right there. Okay. And so that's not good. We don't want flat spots on our roofs. So that's an example of where now we would say, okay, well, let's do a little bit of sloped insulation. Okay, so at this point you could just taper some insulation in a little cricket like this, so that when water comes down, it gets forced over to a drain that would, presumably be sitting somewhere around here. Okay, water comes down, it forces down this cricket. So you have a small area of sloped insulation right there. And that's how you deal with that. And that's kind of the second foundational thing you do when approaching these roofs. So, sometimes you'll end up with an entire grid bay that's flat, and you still just do a sloped insulation around it. I'll just sketch that out here. Okay, so here's a similar building, but I've added one more grid line in the horizontal. So now the roof is like this on this building, and I'll just quickly draw in the high points. So again, high point, low, high, low, low, high. So same as last time. We're going to do two low points there to make sure that the exterior is on a high point, and we're going to have a high point, and we're going to have a low point. And if we did a high here, then we're going to have a low on the exterior, so we don't want that. We want a high point, and then so that means this one here is going to be a low point as well. So let's just do our colors here and see what we end up with on our high points. So high points are on the perimeter, and we got a high point along there again. And so, we would drop a minus 150 here, minus 150 here, minus 150, minus 150, minus 150, and minus 150. Those are going to be our low points where we drop the structure down. And so what we end up with here is a sloped roof that looks like this now. Okay. So again, what that means is here is that this beam here is at a high point there and a low point there. Okay. This beam here is at a high point here and a low point there. And so what that means is that this middle beam is at a low point and a low point. Okay, so again, you would just look at that and deal with that the exact same way we just dealt with in the previous example. And you would just do sloped insulation kind of like that. Okay, so that you would get, if water coming down here, it would be forced down that way into that drain. So now let's just take a look at the other side of this roof and see what happens here. We would now have a situation of this. Okay, now this entire middle portion has become flat. Okay, so if you use the same reasoning of the slope beams, this beam here and this beam here have a high point there, and they have a low point there. These two here have high points here and low points here, and of course the beams in the middle now have low point, low point, low point, low point. So you got a big flat spot on your roof, which isn't ideal. But it happens, and in this case, it would still be beneficial to slope your structure and then just approach that flat spot the same way. I guess it would look something like that. It'd be like a diamond type thing. There'd be a high point in the middle of this thing and tapered insulation outwards, so that when water comes down, it gets down to a drain. So you'd put a drain around each one of these points, I guess, something like that. And actually, it wouldn't look that way. It would look more like this. It would look something like that, and you have a drain there, 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 and there. It gets a little weird, but anyways, that's the whole idea. And you have a high point, and the insulation would slope down to these points, and you just have a large area of sloped insulation there. Okay, we'll just look at one more example here where I just drew in a more odd shaped building just to see what happens here. So I'm going to draw my high points and low points, and now again I want the perimeter walls to be the high point. So in this point, and this would be a high point, right? The, I don't want that to be a low point there because I want this wall to be a high point. So I'm just going to look at that now for a second and say, well, no, because if I made this a low point right here, um, I might have a low point right there, which I don't necessarily want. So I'm just going to say high point, low point, and high point. And again, there's an exterior wall down here. I want that to be a high point along there. Okay, so this way right here, high point, low point. Oh, except I got an issue right there. Let's just put that as high for a sec, high. So we got a bit of a problem here. So we need to have an understanding of which way our beams are running. So let's just say in this case, the beams are running, what color was I using before? Let's just say the beams are running, let's change it. Let's say they're going this way this time. The beams are running this way in this building. And of course, they'd be around the perimeter of the building as well. And so first stab at this, I would just say, okay, well, I can say this could be my minus 150. This could be my minus 150. And obviously when you do that, you end up with something that looks like this as far as the roof slope goes. Okay, so sloping that way, that way, that way, and that way. And, again, you do the sloped insulation here to deal with that. And then, yeah, you got a bit of a problem here. So in this top part here. So, because if the beams are going this way, your joists are running this way, there's not, and if there's only one beam running across here, you certainly don't want to lower that side of the beam or lower that side of the beam. Like, you could make a low point over here, let's say on the left, but you don't want water concentrating near your parapet edge. That's like the weakest point of your building for water to get in over time. So let's just stay away from that. The idea is to get the water away from the parapet. So what would I do in this case? So this beam here, this one here is flat. So probably I would do a sloped insulation package for this whole portion right here. And I would slope it down and I'd make sure that my parapets were high enough to deal with that sloped insulation. And the same would happen down here as well. So that's the approach of how to, take a stab at laying out structure in your building. There's cases where it's not feasible, to slope the structure at all. It's just way too complex and it's just not working out. And that would be an example of where you go to sloped insulation package. But certainly, this is the approach to it, and you just have to play with it and think about it and see if something can be done. And now the other option that someone could do here as well, which would be just fine as well, if you assume that the structure point was 0 here, you could certainly raise this to plus 150, plus 150. And same thing down here, you could say plus 150, plus 150. And so what that would mean is the beam going from here to here and from there to there, make that thicker, would be at a low point on this end and a high point on that end. And then you wouldn't have to do any sloped insulation on there. So that's another option you could do. You just have to look at maybe your cladding. I think the only reason you maybe not want to do that, it's fine. I mean, if you had, I was going to say if you have like an eave system, yeah, if it's an eave system, you'd have like a deflection joint underneath the beam. So it's kind of nice to keep that joint at a consistent height, but it could still be done actually. So yeah, that would probably be a good option there. It's just you wouldn't have a level structure around the whole perimeter. It'd be a little bit higher at this, a little bit higher at this end and a little bit higher at that end. And that would work as well. Okay, so this final one that we'll look at here, I popped some mechanical units on the roof, some rooftop units. I put a mechanical penthouse on the roof, and that could be an elevator overrun. And let's just talk about a few items here. So I'll just go by starting off by laying out the slopes in the building. And I actually modeled this, I copied an actual building here where I noticed on the drawings there were some issues with clarity to the roof sloping. So I'm just going to work it out right here in this video. So again, I'm just going to look at this quickly and say, okay, I've got a high point here and then low, high, low, high. I think that works out pretty good knowing my mechanical penthouse is there. And if I work my way along here, if I said that's high, I'll get to why I'm doing that in a minute. High, low, high, low, high. That works out pretty good. Got a high point on the perimeter. And for this one here, we could say high, low. I would probably do low again and high so that I get a high point on the perimeter again right there. So let's just draw in our roof slopes, assuming the beams are running vertically in this building, we would have a situation, high, low, high, we'd have a situation like this. Okay, and like that, flat spot there and some slopes there, and then here we would have high, low, high. So this one here is going to be, oh, this is an interesting one right here. So what, it depends where the column would be in this thing, but the beam is probably running, let's just say we have a beam running this way, and then we have a beam running this way. Either the column would be here or there, and the beam would either cantilever over the column or the column would be at the exterior wall. But either way, it still works out there. So what I would do in this case is if I had one beam doing that and one beam doing that, then I would just lower this point, the minus 150. So and then you'd end up with something like this. Okay, and high, and then again that would be a low point there. So you could do something like that there. And now what I would do in this case, let's just put in some roof drains here in a different color. So we'd have a roof drain there, and a roof drain there, there, and there. We'd have one around here, and we'd have one there. And then we'd have our sloped insulation at these flat spots. Okay, like so. And those two are okay. Now we've pretty much put two high points here on each side of the mechanical room, and I did that on purpose. It just happened to work out that way. But what I would do in this case is, this is a high point along here, and this is a high point along here. So these beams here are installed flat, basically. And so I would probably just approach this area in here as being either sloped insulation to a drain itself, or in this case, it's a pretty small roof area. So I would probably just put a high point of the insulation there and slope it down that way and slope it down that way. And I do the same thing here. But, certainly you could do a drain in the middle and do something like that, I suppose. It would work as well. But yeah, I'll just stick with what I wanted to do there. And the other things I wanted to talk about here, this could be an elevator overrun. So if we look at this situation here, oh, I didn't put that in a very good spot to have this discussion. Let's just, let's move that elevator. Let's just say it pops up. Let's just say it's right here. Okay, that's the elevator overrun right there. So when you look at this, the water is now draining down this way and this way right here from that high point. So water is going to be draining here and getting stuck against the curb of that rooftop unit. So you don't want that. So there's always little places on the roof where you have what we call crickets, little built up insulations and crickets like that. So water is forced around that item. So you do that like at an elevator overrun, and not to mention the elevator overrun itself would want to slope, not be flat. So you want to slope it somewhere. So it makes sense to slope it off this side because once the water gets down, it's going to make its way that way. So, depending on whether there's a parapet in there or you just, it depends. You could just run it off the edge depending how high that is. And then over here, oh, I thought I had some rooftop units in here, but the same principles apply. So if we had a rooftop unit sitting, right here, let's say, and right here, then again, you would want to just make sure that the slope goes around that rooftop unit so that there was a high point right here. And then in this case, if we zoomed in here, you would build a little insulation cricket in behind there, like so, so that water can flow around that thing and get down here and flow down like that. So those are called crickets, and they're sloped insulation usually, and you want to identify those areas on your roof plans so that the roofing people that are bidding on the project know what they have to deal with. And that's in a nutshell how you kind of approach sloping a structure.